Hi there, and welcome to this lesson. In this lesson, we'll be doing more WAEC revision, okay? But this time around, we'll be learning about Surds, okay? So the last time we did indices, this time around we're doing Surds. Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into it. So, Surds. Now, at this point, you should be very familiar with Surds, but we'll just go over some of the basics, okay, as regards Surds. Basically, what the key points, the really important things that you need to take note of when you're working with Surds. And the first of which, we have the basic forms of Surds. And basically, what this is about, you have a Surd like this, root 50, okay, and you need to express this in its basic form. And what this is basically it's pretty much to reduce this to its lowest terms in a way, and reduce this to its lowest term. What you do is basically you have 50. 50 is 25 times 2, so you look for the square, you look in 50 to find a square root number, okay, and there's a square number, not a square root number, a square number, and the square number in 50 is 25, okay, and then you split, you say 50 is 25 times 2, and then you have 25, root 25 times 2, root 25 times root 2, and root 25 gives you 5. So expressing 15 in its basic form, you have 5 root 2. Now similarly, if you had 108, you can't find the root of 108, but right there in 108 there is a square number. Okay, if you break 108 down to its factors, there is a square number somewhere there, and I'll tell you that square number is 36. Okay, because if you multiply 36 by 3, you do end up with 108, and 36 is a square number, because if we find the square root of 36, we end up with 6. Okay, so what it is, 108 is 6 root 3 in its basic form, okay, and that's it. That's basic forms, okay, reducing surds to their basic form. And then the next thing we need to learn about basic operations on surds. So how do we add, multiply, divide, subtract surds? Quite simply, we do so similarly to the way we work in algebra, okay. So you can add root 3 and root 3 together. So for example, in this case, you have 5 root 3 minus 3 root 3. That gives you 2 root 3. Okay, and then you can't add root 3 and root 2 together. Just like you can't add x and y together, but if you can add 5x plus 3x, so 5x minus 3x. Just the same way, it pretty much follows the same process in algebra. Okay, you apply that to working with surds. Now, similarly, if you're looking to multiply, you can multiply any form of surds. Okay, so just like in algebra, you can multiply x and y to give you xy. You can multiply root 3 and root 2 to give you root 6. Okay, and basically 5 root 3 times 2 root 2, you multiply the two whole numbers, so you have 5 times 2 gives you 10, and then root 3 times root 2 gives you root 6. Now, what if you're looking to multiply 5 root 3 by 3 root 3? Okay, what you do is you multiply the two whole numbers, would give you 15. So 5 times 3, 15. And then you multiply the surds. So we have root 3 times root 3. Root 3 times root 3 is the same as root 3 squared, and that actually gives you 3. So root 3 times root 3 is 3. And then you say 15 times 3, and you have 45 in the end. Okay, now let's talk about the conjugate of a surd. This is another very important one you need to take note of when you're working with surds. The conjugate of a surd, and if you have basically it's the when we talk conjugates when we're working with binomial expressions, basically an expression, a surd expression that involves two units, two terms. Okay, so we have, in the case like this, we have 3 plus 5 root 3. So when you have two things at play, where surd is involved, basically that's where you're dealing with a conjugate of surd. And the conjugate of this surd, quite simply, is just changing the sign in the middle there. Okay, so the conjugate of 3 plus 5 root 3 is 3 minus 5 root 3. That's simple. Okay, simple, straightforward. So if you had root 7 minus 4, the conjugate of that sort would be root 7 plus 4. Okay, very simple, very straightforward. Now, the relevance of this we would find out shortly, but one very important property of this is that when you multiply a surd by its conjugate, okay, if you expand this out, you should have 3 times 3 would give you 9. 3 times minus 5 root 3 will give you minus 15 root 3. 5 root 3 times 3 would give you plus 15 root 3. And then you have 5 root 3 times minus 5 root 3 giving you minus 75. Now, what you notice is that the middle terms here would cancel. And what you have in the end is you have minus 66. Or if you just apply the law of difference of two squares, okay, if you recall, basically the law of difference of two squares applies here, and what you have is you just square the two terms there and find the difference of the two, and you still end up with minus 66. And the very important property of this, the conjugate of surd, is that if you ever multiply a surd by its conjugate, you would end up with a whole number. Okay, multiplying a surd by its conjugate would get rid of all the surds in the expression, and you will most definitely end up with a whole number. And that is actually very relevant for this next bit, rationalizing the denominator. Okay, now generally when we have surds like this in fraction form, we generally do not like surds as denominators. Okay, so we will like whole numbers there as denominators. So we're often given a surd like this. What you have to do is you need to rationalize this surd, and to do that you quite simply multiply the numerator and the denominator by the denominator. So in this case we have root 3 as a denominator, and we just multiply the numerator and the denominator by that denominator, and what we have in the end is we have 2 times root 3 gives you 2 root 3, and then root 3 times root 3 gives you 3. Now, 2 over root 3 and 2 root 3 over 3 are the exact same thing in terms of value. Okay, they represent the exact same quantity. Alright, but generally we prefer to present surds in this manner, okay, where the denominator is not a surd, okay, and basically we call rationalizing the denominator. We do not want an irrational number or a surd as the denominator. We want to rationalize this fraction such that, rationalize the denominator in this fraction such that the denominator becomes a whole number or a rational number. Now, what if you had a surd like this in this form? So you have a fraction, and then the denominator of the surd is a binomial. Okay, you're looking to rationalize the surd, and remember the objective is to work it such that that base number, that denominator, is no longer a surd. It becomes a whole number. What do you think you would apply here? You'd multiply by the conjugate, okay, and this is where the conjugates become relevant. So if you multiply this by the conjugate, you would end up with a surd expression on the top, but definitely you end up with a whole number at the bottom. Okay, and this is the one way you'd multiply this surd, and that will result in a whole number. So when you're rationalizing the denominator of a surd, where you have an expression, a binomial expression with two units, where basically where you with addition or subtraction, you rationalize using the conjugate of that surd. Okay, and what you have in the end is you end up with a whole number, and you can just simplify this out, and what you have is you have 3 plus root 7 divided by 8. So if you have all of these embedded in your head, you should have absolutely no problems whatsoever attempting questions on surds. Okay, so you know how to express surds in their basic forms, you know how to perform basic operations on surds, you know how to work the conjugate of a surd, and you know how to rationalize the denominator of a surd. Now let's go ahead and do some examples. So we have example 1. Example 1, simplify 7 root 5 over root 7 by rationalizing the denominator. This is quite simple. Okay, so we're just going to take our denominator there. The denominator is root 7, and to rationalize this denominator, we're just going to multiply the numerator and the denominator by root 7. And what we have is we have 7 root 5 times root 7. The root 5 times the root 7 will give you root 35. And what you have is you have 7 root 35. And then the root 7 times 7 would give you 7. Okay, and then you can cancel out the 7's there, and what you have in the end, quite simply, very nicely, is root 35. Simple, straightforward. Let's do another example. example 2, okay? And example 2, we have simplify 8 minus 4 root 18 over root 50, leaving your answer in the form a plus b root n, where a and b are rational number and n is an integer. Basically, what this is quite simply, we're just looking to rationalize that denominator. So simplify this expression, leaving your answer in the form a plus b root n. So what that's pretty much just telling you it should not have a surd denominator. Okay, quite simply, where a and b are rational numbers, okay, and n is an integer. Now, quite simply, we're going to rationalize this surd, okay? And to do that, the first thing we're going to do, because we have some big numbers there, we're going to simplify first, okay? And in this case, we have root 18, root 50, root 18. There is a square number there. That square number is 9, okay, in root 18. And then in root 50, the square number there is 25. So when you work that, you should end up with root 18 becomes 3 root 2. Okay, so you have 4 root 18 becomes 3, 4 times 3 root 2, that's 12 root 2. And then you have root 50 as 5 root 2. And the next big thing you want to do is you want to rationalize this surd here. You want to rationalize this expression, and what you do, you look at the denominator there. The denominator there is 5 root 2, and I should tell you, when you're rationalizing a surd, you do not necessarily need to make use of the whole expression. Just the surd will suffice. So you don't need to rationalize with 5 root 2. That will just give you very, very bulky numbers. You can rationalize with just root 2 because it will give you the exact same result. Okay, and then in this case, we're rationalizing with root 2, and what that does, it does exactly what we want it to. It eliminates the surd at the bottom because root 2 times root 2 gives you 2. And then you have 2 times 5 gives you 10. And then when you multiply the numerator there by root 2, you have 8 times root 2 minus 24. Okay, 12 root 2 times root 2 will give you 12. Root 2 times root 2 will give you 2. So you have 12 times 2 giving you 24. And then, quite simply, when you simplify that out, you end up with 4 over 5 root 2 minus 2 whole number 2 over 5. Okay, and then basically we're just going to arrange this. So the whole number is in front, and then the set, because we're trying to get it to fit to a plus b root n. And when you work it like this, you'd find that your a is minus 2 over 5, and your b is 4 over 5, and basically n is your 2. N is 2. So basically we've simplified this expression, and we have our a and b as rational numbers, okay, and then n as an integer 2. Simple, straightforward. Next example, example 3. And we have simplified 5 root 3 minus 3 root 2. 5 root 3 minus 3 root 2. Now, quite simply, basically, this is just a very simple fraction. And we're going to work that. We find the denominator there. The denominator will be root 3 times root 2 gives you root 6. Okay. And then you divide root 6 by root 3. That will give you root 2 multiplied by 5, that gives you 5 root 2. So you just work this like you would a normal fraction. And then you have root 6 divided by root 2, that gives you root 3. And then root 3 times the 3 on the top there gives you 3 root 3. Okay, and basically you have that. The next thing you want to do is you want to rationalize. Okay, get rid of the root 6 on the bottom there. And you do that. Root 6 times root 6 gives you 6. You have 5 root 2 times root 6 gives you 5 root 12, minus 3 root 3 times root 6 gives you 3 minus 3 root 18. And then you work this. When you simplify, you have 10 root 3 minus 9 root 2, okay? Because in root 12, you have 4 there. So you can simplify that to give you 2 root 3, okay? Multiply that by 5 gives you 10. And then similarly, you do the same for root 18. And root 18 would give you 3 root 2 times 3 gives you 9. So that's what you have there. And yeah, that's it. Basically simplified 10 root 3 minus 9 root 2 divided by 6. Next example. Example 4. Okay, so we have simplified this, and quite simply 20 divided by 5 root 28 minus 2 root 63. Okay, and we have 2 there. Okay, and basically what we have there, if we simplify that out, what we have is we have 20 divided by 10 root 7 minus 6 root 7. Okay, 20 divided by 4 root 7. We will rationalize using root 7. We should end up with 20 root 7 divided by 28. And what we have in the end is we have 5 root 7 over 7. Simple, straightforward. The final example we have, this looks very interesting, but really simple to be honest. So we have 5 over root 7 minus root 3 plus 1 over root 7 plus root 3, and basically we just work, is the fraction there, so we'll work the denominator, we'll multiply the two expressions. They're actually conjugates, okay, so that makes things very, very interesting. So we have 7 root 7 minus root 3 and root 7 plus root 3. So root 7, and then we divide that expression by root 7 minus root 3 and gives you root 7 plus root 3. You multiply that by 5, and then just basically working this like you would a fraction. And then similarly, the fraction on the bottom there, that's root 7 minus root 3 multiplied by root 7 plus root 3. That expression divided by root 7 plus root 3 multiplied by 1 gives you root 7 minus root 3. And then you just go ahead and simplify. Okay, when you work out that conjugate multiplication there, you end up with 4. And then what you have on the top there gives you 6 root 7 plus 4 root 3. And when you simplify that out, you have 3 root 7 plus 2 root 3. And that's it. Very simple, very straightforward. And that would bring us to the end of this lesson. Okay, we've been doing surds, and these are the typical kind of questions that you'd expect on WAEC when you're working with surds. And like I said, you just need to know 4 things. You need to know how to simplify surds to their basic forms. You need to know how to work basic operations on surds. You need to know how to work the conjugate of a surd, and then you need to learn, very importantly, pretty much every question, some would always involve rationalizing the denominator. It's pretty much the most important one there, but then all of the rest come in very, very handy. But yeah, and you can go ahead now and attempt questions on the worksheet. Bye for now.